Momentum, impulse. Remember impulse? We talked about it with momentum. All right, it equals the change momentum, usually applied to an object, but maybe to a system. Remember, it was written as a capital J equals delta P, and again, those should both be vectors. But this is an old PowerPoint that I adapted. So, where did it come from, mathematically speaking? So, Newton's second law that you learned in 8th grade science, maybe, or that you learned to recite, F equals ma. Well, not quite. Newton's real second law that he actually wrote in 1687. Anyone speak Latin? Well, it turns out Google Translate kinda does. The alteration of motion is ever proportional to the motive force impressed and is made in accordance with the right line in which that force is impressed. Whoa. What? What? That still doesn't make sense. Here it is again. What does it mean? Well, it means the change in momentum of an object, right? The alteration of motion is proportional to the net force, and it goes in the same direction. That's all it means. So, why did Newton have to invent calculus? Well, if the net force, all right, which we'll get to why it's the net force, all right, equals mass times acceleration, which is close to what you learned before, all right? And you take the acceleration as the change in velocity over change in time, except he did it in a calculus version. Here we use deltas. You put those together, and you substitute out delta V over delta T for the acceleration, and holy moly, we have the net force equals mass times change in velocity over change in time. That would be the change in momentum over time, because Newton assumed that the mass was constant. And in most of our problems, it will be, so we can use his equation. So, what does that mean? All right, so if we take this new m delta v delta t, right, switch it up, right, I can do this, it's all multiplication and division, all right, you can actually see where f equals delta p over t, all right, if we assume that our initial t is 0. So I've left out the net force here, all right, it really should be in these equations, but at least this is kind of how the algebra works. Okay, so you can also rearrange this to say that your delta P equals the net force times time. So this equation here, net force times time equals the change in momentum, which we also know as impulse. Well, that's actually just called the impulse momentum change theory, okay? Or you might just see momentum impulse. Either way. Okay, so if we look at this, what must the other units for impulse be besides kilograms, meters per second? A Newton times a second. So, hopefully, all right, this equation will start to make more sense as we go through.